Hey guys, Mr. Milton here. Today we are going to look at trapezoids and kites. At the end of this lesson, you should be able to use the properties of trapezoids and kites to find the missing side lengths and angle measures. Okay, so before we start, we need to remember a couple things about the figures we've already talked about. A trapezoid is a quadrilateral that has exactly one pair of parallel sides. Okay, this is from its definition. And an isosceles trapezoid is a trapezoid whose non-parallel sides are congruent. Okay, those are from the definition from our first classifying quadrilaterals lesson. Okay, a kite is a quadrilateral with two pairs of adjacent sides that are congruent. Adjacent means next to. And no opposite sides congruent. Okay, that way a kite and a rhombus cannot be the same. Okay, and then of the quadrilaterals we study, these are the only ones that are not parallelograms. So these are not parallelograms. None of the properties of parallelograms apply to these. Okay, so we'll talk about a few properties of trapezoids and properties of kites today and be able to use those. So the first property of trapezoids is that the base angles of an isosceles trapezoid, okay, and notice that this is isosceles. There's not trapezoids come in all different shapes, so there's a lot of variation with that. But with isosceles trapezoids, there's a property we can use that the base angles are congruent. Okay, when we talk about base, there are two bases of a trapezoid. Top base, you call it base 1 if you want to. The bottom base, base 2. All right. So identify the base angle that goes with B, and then find the measure of each angle. So the base angle that's associated with angle B, so angle B here, what else is a part of that base? Angle C. Okay. Our property says that the base angles are going to be the same, so even though these are listed out here, C is associated with B, so it's going to be the same. C should be 102. Okay, notice that, and remember that a trapezoid has two parallel sides. So these are parallel. You can see this as a transversal. These are same side interior angles, and so that means they should be supplementary. This is 102. That means angle A will be 78. This will also be 78. Again, notice that the base angles that are associated with each other are congruent. So now filling in our answers, angle A is 78 degrees, angle C is 102 degrees, angle D is 78 degrees. Okay, so one thing that we should remember about trapezoids is that the base angles are, in isosceles trapezoids, are congruent. Okay, second thing, still pertaining to isosceles trapezoids only, is that the diagonals of an isosceles triangle are congruent. Okay, and here we're going to prove the diagonals of an isosceles triangle are congruent. If you look at this proof, it wants us to prove that AC is congruent to BD. Okay, this should be reminiscent of the overlapping triangle proof that we had to do in the first semester. So let's go through this. Our given statements are given to us in our diagram. We are given that AB is congruent to DC. Given. Okay. We're also given that AD is parallel to BC. Given. Okay, and so now we're going to build off of that in order to be able to find some, to prove that AC is congruent to BD. So we're proving AC is congruent to BD. We're proving parts congruent. We should know we're going to CPCTC. Corresponding parts of congruent triangles are congruent. So we have to prove two triangles congruent. So we're going to be looking at AD or DB and AC. We could be dealing with a couple different triangles, but let's work with it. So from here, knowing that these two angles are congruent and also knowing that our base angles are congruent, we can look at a couple things. I am going to see that in this triangle ADC and in this triangle ABD, they share a side. They both share AD. So AD is congruent to AD, and that is the reflexive property. by the reflexive property. Reflexive property. Okay, I'm going to redraw my triangles out here just so I can have them. This is A, D, B. This will be A, D, C. Okay, and so again, we just showed that those are overlapping. I'll give them 2 marks. We were given that those are congruent. We also know that it's parallel. Okay. The next thing that we can use actually comes from our first property. We know that the base angles of isosceles trapezoids are congruent. So first I'm going to make sure that I know that, hey, this is an isosceles trapezoid. D, C, B is an isosceles trapezoid. Okay, and that's based off the definition of an isosceles trapezoid. Okay, so using these 2 pieces of information to go there. And so now I can say that their base angles, these 2 angles are congruent. So angle BAD is congruent to angle CDA. And that's because base angles of isosceles trapezoids are congruent. Okay, long explanation right from our first property that we talked about today. All right, so now you should see that we have side, angle, side. We can prove that these 2 triangles are congruent. So actually, triangle BAD is congruent to triangle CDA by side, angle, side. Okay, and since that's true, then I can say that BD is congruent to AC by CPCTC, corresponding parts of congruent triangles, CPCTC. Corresponding parts of congruent triangles are congruent. Whew. All right. So again, major takeaway is that the diagonals of an isosceles trapezoid are congruent. Okay, these are 2 things that you need to know about trapezoids. Flip it to the back. Kites. Okay, for kites, their diagonals are perpendicular. Perpendicular. Okay, and so we can use this to find missing measurements as well. Since we know that their diagonals are perpendicular, remember that means make 90-degree angles. We can solve for the missing angles. They told us that this is 32 degrees. Since our diagonals are perpendicular, we know all these are 90. Okay, and remember that we can use our triangle knowledge. 90 plus 32 is 122. We know a triangle should add up to 180, and so that will make this 122, 180, 858. The measure of angle 1 is 90. The measure of angle 2 is 58. Okay. All right, now we had to find this angle, angle 3. I'm going to just add in some geometry here. Since these 2 adjacent sides are congruent, right? This is A, B, and C. If angle 2 is 58 degrees, this angle here also has to be 58 degrees because this is an isosceles triangle. Right, so the base angles will be congruent. Okay, that helps us out because we already know this is 90. So 58, 90, that means this would have to be 32 degrees as well. So the measure of angle 3 is 32 degrees. Okay. All right, and then finally, we want to show that angle 1 is congruent to angle 2. We want to prove it, and then find the measures of the angles. So let's talk about this. We see that this is a kite, and we can tell because we have 2 pairs of adjacent sides that are congruent, but no opposite sides that are congruent. All right, and what I will do is I'll look at this as triangles. Okay, so I'm going to draw this left side as a triangle here. I'm going to draw a line down the center here, okay, just for this proof. Okay, I'll do the same thing on the other side. Kind of drew it wrong, but you'll know that I'm going for this. All right. what you should see is that we have these two sides already given to us as congruent. This middle side is a shared side. So we can see that the two triangles are congruent because of side, side, side congruency. Okay, so they have to be the same. Because they have to be the same, we can see that angle 1 and angle 2 are corresponding parts. So they will be the same. So, in a quadrilateral, there's 360 degrees. These two take up 146 degrees together. So 360 minus 146 will give us 411. Nope. Yep. Nope. 214. Okay, 214. Okay, divided by 2, that means that they will both be 107 degrees. Okay, there's 214 degrees left in this shape. There's two congruent angles left. They will be 107 degrees each. All right, finally, we are going to look at the trapezoid midsegment theorem. And what that says, a midsegment of a trapezoid is a segment that joins the midpoints of the opposite sides of a trapezoid. All right, opposite, let's say non-parallel. Non-parallel. Okay, so the midsegment of a trapezoid is parallel to the basis. And its length is half the sum of the bases. So this is how we find that. In order to find the value of x, it's the midsegment. Okay, we can tell because these are congruent. So x will equal half the sum of its bases. One base is 21, the other base is 35. So those together give us 56. Half of 56 is 28. 28. So x is 28. Okay, next it says if the measure of angle A is 100 degrees, what will the measure of angle DEF be? So DEF. All right. Talking about this angle, we see that these are parallel lines, right? Parallel lines here, transversal. Angle A and angle DEF are corresponding angles, so that should be 100 degrees. Finally, it says if angle C is 75 degrees, find the measure of angle EFC. EFC. Okay. Now, we're looking at this. You see that that means these are still parallel. So we have parallel angles here. These two angles together now would be same side interior angles, which are supplementary. Am I right on that? Or am I wrong? Did I do that right? Okay. Are supplementary. So that means in this case, remember these are separate problems. In this case, these are supplementary. So that would be 105 degrees. All right. So things that you should remember from this lesson is that the base angles of an isosceles trapezoid are congruent. The diagonals of an isosceles trapezoid are congruent. The diagonals of a kite are perpendicular. And you should be able to find the midsegment, use the midsegment to find missing values in a trapezoid. Okay? All right. See ya.